Hi everyone, welcome to our webinar, Unlocking Data Lakehouse for Insurance. I am Richa Yadav, and on behalf of WalkingTree Technologies, I'm absolutely delighted to have you all with us today. We have got an exciting session lined up where we'll explore how to unlock the power of Data Lakehouse. Before we dive in, let's take a quick second to welcome those who are just joining us. For those who are new to WalkingTree Technologies, a big warm welcome. We are a company that lives and breathes innovation, constantly pushing the limits of what technology can achieve. We specialize in cutting edge tech solutions, especially in artificial intelligence and open source frameworks. Our mission is simple yet powerful to empower businesses by implementing state of art technologies that drive efficiency, scalability, and innovation. Today, we are going to focus on one of the hottest topics in tech right now, unlocking data lakehouse for insurance. Throughout this session, we'll explore how to unlock the power of data lakehouse to drive smarter underwriting, faster claims, and personalized customer experience in insurance. All right, without further ado, let me introduce our fantastic speakers for today's session. First up, we are honored to have Suman Raburi, our VP Engineering, specializes in digital transformation with over a decade of experience at WalkingTree. He has built high-performing teams, executed complex projects, and fostered a culture of continuous learning. Next, we have Narendra, our brilliant AWS certified solution architect, has over a decade of experience in application development, mobile applications, and DevOps. His expertise spans technologies like J2EE, Angular, AWS, and Kubernetes. And he is passionate about mentoring and innovation. All right, let's get started. Suman, the virtual stage is yours. Let's explore together how to unlock the power of data lakehouse.
Thank you, Richa. Thank you all for joining. Good evening, good morning, based on the place from where you joined. Uh, Without further ado, I'm getting into the direct agenda. So, uh, so what we are going to cover is that what kind of data challenges, data processing challenges we primarily face in BFSI in general and in specific insurance domain. Uh, so the first step I'm covering, I'll be taking one use case and what kind of a data challenges, processing challenges we end up as a primarily the technology implementers. Okay. Then after that, my colleague Narendra will be covering Delta Lake ecosystem. So based on these challenges, to address these challenges, how Delta Lake uh, is built and how it's going to solve this kind of problem. So Narendra will be covering Delta Lake. Then after that, I'll be covering different use cases, uh, advanced use cases that we can think of implementing using Delta Lake, and how these use cases help overall for a better customer experience or overall efficiency in our entire insurance process. After that, Narendra is going to give a live demo. So live demo is a technical demo where he's going to uh, process certain claims, uh, create certain claims, and show a different features of a Delta Lake, different technical features of Delta Lake. So after that, we get to the final Q&A session. Before we start discussing about the challenges, so I'll be taking one a typical insurance use case. So a very regular use case. Most of us might have been exposed to this kind of user use case, maybe as a user itself. So generally, the policy user holder visits hospital, then submits a claim via portal. Sometimes the claim can come from hospital or sometimes from the policy holder. Then system takes that claim. Then document validation needs to happen. Then you need to do some kind of any fraud check kind of stuff. And based on these two, document validation and the fraud check, we'll check, system will check whether the claim is valid or not. If the claim is valid, initiate a settlement process. If no, notify the rejection. And after some time, once this claim is done, after some time, you need to archive the case. Okay, archive the claim. Okay, so this is a very standard, a regular insurance use case. Okay, So we take this example, and by taking this example, we understand what kind of a data processing challenges that we get in, and how do we address. That's what we're going to cover now. Yeah, let's move to the next slide. So primarily the data challenges, I am kind of categorizing into three different aspects. Primarily three V's, because of volume, velocity, and variety of the data. Then a compliance and regulatory needs, and expectation of the need for the real-time response. Okay, so primarily we'll have these kind of three different expectations are there, and these expectations, how they will lead to challenges, we'll cover bit deep now. Okay, yeah, let's move to the next slide. I'll be covering three V's first. So primarily in three V's, you see variety, volume, and velocity. So, so in terms of variety, if you take the use case that we have discussed, so we have a policy records and transactions. So policy records is that okay, so and so customer has a policy holder has a policy record stored in our insurance system, and generally these policy records are a structured data. The data is available in the structured format. Then the transactions in terms of when the policy is enabled, and uh, when all the transactions in terms of payments, any claims that happened so far, or is the policy still active, or is policies became invalid. Okay, so all the transactions data is also available. So generally these policy records and transactions both are available in some kind of a structured data. Okay, so in terms of variety, we have a structured data available. We have a structured data. Then when we look at the claim documents, so generally people submit the claim documents. A claim documents means, okay, patient's diagnosis information, or like maybe the tests that the user has gone through, and the kind of procedures user has gone through, and all that information is available in the claim documents. A lot of times this data is available in the PDF formats, or sometimes a complex health record information form also. So this is the claim documents, and then other is the logs, because many times this insurance uh, claim process goes through the sometimes uh, policy holder or TPAs reach out to the uh, call center, and these call center logs will also be there, and sometimes they do the communication to insurance company through emails. Okay, so these claim documents, logs, and emails, mostly they are unstructured data or a semi-structured data. So, so in this simple use case, you have structured data as well as the unstructured data. Okay, so our system should be capable of handling both structured and semi-structured data. Then after this variety, then I'm going to the volume part of it, which is very, very critical. So uh, as world is getting digitalized, and uh, enormous amount of data is getting created, so you'll have millions of policy records, a lot of customer profiles. Many times one customer will have multiple policies, sometimes health insurance, sometimes vehicle insurance, whatnot, asset insurance. So customer profile one customer may have a lot of policies, old policies, all the policy records, the huge volume of policies, a lot of customer profiles, the transaction histories, and then high resolution medical documents. These medical documents, not only they're unstructured, sometimes we end up getting a high resolution medical documents which needs a lot of data storage. Okay. Apart from that, we as a as a system in the insurance system is supposed to technical system is supposed to handle, have expectations of handling millions of claims requests per year, and along with that uh, we have a historical data, fraud detection data. That means if some certain fraud happened, that fraud detection data also is available. So you see, this is a huge volume of data that we handle. Okay, so many times data ending up into millions of the data, millions of records, millions of policies. Then when it is combined with the volume, other important aspect is the velocity. Okay. Example, people expect sometimes our system has a goal that process 100 plus claims per hour. Okay. It is a very moderate goal. Sometimes we end up doing in terms of 10K claims per hour, or sometimes you have to process 1 second one claim, okay, based on the volume of the data. And every day, as the day passes, people are expecting to make the claim processing real time. Okay, if you start taking more time as an insurance company, then you end up having a challenge of a user experience. User starts feeling not so good about you because you're taking a lot of time to process the claim. Okay, so when you combine this, okay, we have a different varieties of the data. We have a large volume of the data, and velocity expectations are also very high. Okay, so this is a three V's. So in that case, we need to build a system that is highly responsive, a resilient system. So yep, so this is one aspect of the data processing challenge. Okay, now we move to the compliance and regulatory. All insurance companies across the world, they are mandated to follow certain compliance and regulatory needs. Different regions or different countries have their own regulatory bodies, but they enforce those regulations on the insurance companies. In turn, the corresponding technology, the corresponding application that process insurance needs to support that. Okay, so different uh, regions, have a different, I can say, nomenclature, but they end up having some common rules. Okay, example, people expect immutable logs, so that every action is recorded: who submitted a claim, who approved it, who updated a given insurance policy, when was paid, who paid it. Okay, all of that information, it should be immutable, so that we know the change that happened on a given entity. Also expects that we should track the user ID, uh, timestamp, and IP address. That means who did, what time the action happened, from where it happened. This information is also expected, so that we can chase, we can go and figure out, okay, particular transaction, why it has happened. Okay. So it's primarily important for the auditing. Then expectation is to have that, okay, we should retain the change history for all claim records. You see this, what I mean to say is that apart from storing a standard data of insurance, we are supposed to store many other relevant information as part of a compliance and regulatory needs. And this is important because ultimately we are all serving customers, so we should make sure that customer experience and uh, their data is protected. Apart from these audit trails, data privacy is also an important aspect. Again, European region has a GDPR standards. California has their own standards. Australia recently brought up their own data privacy standards. So different countries or regions have their own regulation standards, but broadly they get classified into the following stuff. So they kind of recommend store only data that is essential. Okay, so minimize the data that is storage, and this is important. Data access, a correction and deletion request. That means finally end user, the policy holder, should have access, uh, should have a permission to access the data, to correct the data, and to delete the data. So this we should enable, because if a particular policy holder says, okay, anyway, I close the policy, I do not want my data to be with you, and he should be able to make that request, then our system should facilitate that. This is another important aspect. So most of the regulations across the world, they're making this as a mandatory stuff. And second is, we need to, in case if you are talking about healthcare, health insurance, then if you are storing health data, you should do the end-to-end encryption of the health data. The reason is that even if due to some reason, if the data is access is compromised, but still people should not be able to read and understand and interpret the data. And third is a consent tracking. The last option is the consent tracking. So the consent tracking is that means sometimes we may, as an insurance product, we may end up sharing the data to some third-party TPAs or other systems, but with a consent of the user only. Because if user is not giving the consent, we should not share it. Okay. So consent tracking is also important. That means our system should make a record of, okay, okay, who initiated the request, whether user gave the consent, if user gave the consent, what time he gave a consent, in what form he gave a consent, and so that uh, uh, data access was shared to other systems only with the consent of the user. Okay. Next. Then the next is the real-time response. So this is primarily the user aspect of it, where uh, policy holders expect a faster claim processing. So that if you delay the claim processing, you reduce customer satisfaction. Uh, and the side effect is that you get more calls into call center. You need to put more people in the call center. So it has all kind of side effects. So we should do the faster claim processing. The next is the fraud detection. The fraud detection is becoming more and more challenging, and as our technologies are advancing, the people who wants to do the fraud also they are getting better on the technology. So we need to do the real-time validation so that fraudulent claims are not happening. Okay, so this is primarily the efficiency of our system. Okay, our overall insurance company. Okay? The next is the dynamic policy validation. So, example, maybe when people are applying claim, so there itself system should be able to do the on fly. Okay, balance limits. How much balance limits are there? Is the maybe if the system can inform. Okay, this much of claim is anyway possible with this kind of request. So that's the dynamic policy validation. And a third party coordination, because you'll have multiple layers, because when the insurance platform is going to talk to multiple third party systems, be it hospitals, be it TPS, be it a verification systems. So all these integrations should happen in the real time. Then, last but not least, instant notifications also, that people expect real-time notifications. Uh, may not be even end user. It could be even TPS expect real-time notification. Hospitals expect real-time notifications. Okay, so it should be communicated with in a near real time or real time. So these are the different challenges. So now what my colleague Narendra will take over. What he will do is that, okay, to solve these uh, data processing challenges, how we were doing earlier, and what Delta Lake or Data Lakehouse architecture will help to do the things better. What's the differentiation that Delta Lake is bringing in to the table?
Yeah, thank you so much, Suman, for briefing about all the BFSI challenges. So before going to this data lake house, I will take a second for the for data evaluation, how data evaluated. So initial days when internet is growing, the business entities start looking for they are converting their offline services into online. So initially the requirement is just users whatever they will enter, we will store in the database like OLTP databases, and we will retrieve that data. But day by day, business entities started looking for the customer insights and with their data, what they are doing, all this has happened. So then we came up with a data warehouses where OLAP database are serving the analytics process. So the problem with the data warehouses is basically it's a fixed schema, and it can handle only structured data. So, and the compute and storage are including the same area, so that the scalability is also very less in data warehouses. Then people start moving to the data lakes. So basically, data lakes came up with the like storing the structured data, semi-structured data, all this data. But the finally, like basically, what we missed in the data lake was the ACID transactions. Basically, we are storing the file format in the data lakes. So where we have like there is no features like atomicity, consistency, like these details. And the second is the performance issues we have seen in the data, because we need to build the data warehouse on top of the data warehouse or data lake. So it's going to be cost effective, and it's going to take a huge time. Then people started like, why can't we combine the data warehouse plus delta lake features? So that's where data lake house system emerged. Oh, Richard, can you please move to the next slide? So if you come to this lake house architecture is nothing but a combination of the data warehouse plus data lake. So what people thought when we are building a lake house, so they want to, on top of the file formats we are storing the data, so they want to provide a transactional attributes like atomicity, consistency, all these features, along with the, and one more feature we lack in the data lake systems are the schema enforcement and schema evaluation, and it will so all these features we brought into the lakehouse architecture, and it will brings our morely structure and reliability to the data lake. So Richard, can you move to the next slide, please? So initially, I think we have seen, right, in insurance system we have the structure, semi-structured, unstructured data. So all this data lake house we are storing with the like in the file format. So where all these files are managing through the metadata, to manage all this metadata. So first they build the metadata layer, and for the performance improvement, caching is the important point here. So metadata and caching and index layer on top of the data lake, they build it. And we have the like SQL APIs to retrieve the data for serving the our BAs and reports. And we have like in the Spark, they have a data frame APIs to serve the data science and machine learning areas. So that's how Lakehouse system has evolved. Can you move to the next slide, Richa, please? So now, what is the Delta Lake? So Delta Lake is one of the solution, like our framework, which is implementing Lakehouse architecture. So it is another transaction layer on top of the our storage data lake storage layers. So there are other implementers also there for building a lakehouse architecture, like we have Apache Iceberg and Apache Hudi. The mainly the key features for the Delta Lake is schema evaluation and schema enforcement and ACID transactions. So we and the time travel. So we can go through the different version of the data, and it will handle the huge data. And in terms of performance, also it can handle the big data. So can you move to the next slide? If you compare the different implementers of the lakehouse architecture, mainly we can see these are the three primary lakehouse implementers. One is Delta Lake. So Delta Lake supports all ACID transactions, schema evaluation, and time travel streaming support. Coming to Iceberg, it will support all the three ACID transactions, schema evaluation, time travel, but not streaming support. Similarly, coming to the Apache Hudi, it will support the ACID transaction and schema evaluation and streaming support, but not the audit data like time travel. You can go through the old version of the system. And in the Delta Lake is tightly bounded with the Apache Spark system. But coming to the Iceberg is a vendor neutral, so you can integrate with any other systems. So these are the prominent implementers in the Delta Lake systems. Now Suman will cover the what are the use cases we can implement through the Delta Lake House architecture.
Sure. Thank you, Narendra. Uh, so with the Delta Lake coming in place, there are we can solve many new use cases or maybe an existing use case in a much more effective way. Okay, so I'll be covering some of the use cases and how these use cases will be useful uh, to have a better customer experience and to make our internal systems more efficient. I mean to say the insurance companies internal systems more efficient. So let's cover this customer 360-degree view. So generally, like as people, insurance customers are engaging in multiple channels. Example, they do a policy purchase through some channel, and they do the claims, and they do a support request to different channels. They do a renewals through some other channel. So the data is kind of being spread across different systems, and then creating a unified real-time 360-degree view data will help insurers to deliver personalized services. So, these personalized services will help, will lead to the customer delight. That means if you can predict that, okay, customer may have this kind of insurance need, and you recommend that insurance, then most likely we will have two things. One is that he'll buy that insurance. Second is that we'll have a delighted customer with us. Okay, and we can also detect the cross policy risks. We'll be able to retain customers for much longer period, and in all we have to do in compliance with the data privacy and regulations. Okay, so what we can do, like we can unify the customer data, combining policy systems, claims, and different data. Then one use case could be that, okay, we can identify the life events like a change of the address. Okay, and maybe if a new addition in the family, maybe the moment you realize that there is a new addition in the family, we can go and inform customer, hey, you have a new addition in the family, you don't need to pay additional, mm, but if you take this top up, then this insurance will cover a new member that got added into the family. Oh, maybe some asset purchase happened. Do you have insurance for that asset or not? So that you can do a cross sell and upsell. Then we can also start detecting inconsistencies. So idea is that sometimes uh, uh, the user details are same, but insurance policies are not related. Okay, altogether different related policies. So this is some inconsistency. So maybe accidentally a contact info is uh, uh, not correct, or maybe it's a fraudulent insurance request, or so we can understand the inconsistencies. Based on the inconsistencies, once we detect inconsistencies, we can take the corresponding actions. Okay, and again, in the customer, we're implementing customer 360 degree, we should be able to have a traceable consent records, so that okay, consent was given by so and so person. So this is kind of a more regulatory need, uh, but the customer 360-degree view will help for a better customer experience, and internally improve the efficiency in our internal systems also. Okay, so earlier also customer 360 degrees were there, but with the data lakehouse architecture in place, or with the Delta Lake implementation, this can be implemented in a much more efficient way. The next is the fraud detection and risk assessment. Uh, uh, this is becoming a challenge, because we should identify fraudulent insurance claims uh, upfront. Because see, what happened is that uh, we should punish a fraudulent person, in terms of we should not do a payout for the fraudulent claim, and at the same time we should do a quick processing for the regular real user. Okay, so in that process, the fraud detection is an important thing, so that we should start identifying that some behavioral anomalies, repeated claims for similar treatments, or sometimes same claims, similar claim came from different hospitals uh, for a same person. Okay, these kind of things we should be able to analyze in near real time, and detect, okay, fraudulent transactions. Apart from that, sometimes we should give a dynamic risk scores also. That means some policies are prone to more risks, So we should give that risk score so that this risk score will be useful in the underwriting process. And even we can give a risk score to the customers also, because if some customer is a high risk customer, that means based on the claim history, uh, or based on the past transactions. Okay, so system can have this kind of scores. These scores will enable us to make sure that we serve real customers better, and at the same time insurance company is protected with by not paying to the fraudulent transaction. Okay. So this can also be implemented effectively with Lakehouse. The third is an important, so dynamic underwriting models. So far, I can say that dynamic underwriting models is picking up. Uh, Generally, the underwriting is being done by expert based on some data assessment that he has. But if these underwriting models can become more dynamic and more personal also, so saying this based on the sensitivity, based on the real time and the historical data, based on some real time data, this underwriting model can assess risk better. Then even you can go for the adaptive pricing engines. So maybe as insurance subscription is going on, if you get additional data, so dynamically the pricing will be either increased or decreased for a given quote. Quote can also be dynamically modified in the process. Other important aspect is explainable underwriting. So the underwriting, when we come up with some kind of underwriting, system should explain why uh, we have considered these aspects of it, why we are doing it. So when we get explainable underwriting, that gives a lot of confidence to the even insurance company as well as the customers also. Okay. So all these things can be achieved uh, through this uh, data lake warehouse, data lake house. So, but these are all the different use cases. We are not planning to show the implementation of all these use cases here. So, in the next slide, what Narendra will be covering is that he'll be taking data Delta Lake implementation, and he'll cover the technical aspects of Delta Lake, and those technical aspects in turn can be mapped into uh, these functional use cases. Okay. Yeah. Over to you, Narendra.
Yeah, thank you so much, Suman. So let me share my screen. For this webinar, what I have done is like I have created a Docker Compose file. So basically, I'm launching Spark clusters like with one master and one worker node, and I'm launching Kafka so to stream the live data, and I'm using the Minio as a storage. So Minio is the S3 compatible open source storage. So I already launched all these Docker containers in my local system. So now I'm going to first I'm going to create a Spark session. So I have given the all the configuration related to Minio and all the my Spark session details. So I'm going to execute the Spark session here. You guys able to see?
Yep, yep.
Yeah. So now I have created a Spark session. So if I go to the Spark page, you can see the session here. You can see the running application. This is the my session name, insurance test. So once I have created the Spark session. Now I'm going to create a claims schema in the Delta Lake uh, through the Delta Lake in the Minio. So I'm trying to create a claims schema now, and I'm inserting the like two records of the claims. Yeah, now you can see its execution is completed. Now, if you go to the claims bucket in the Minio, you can see the claims table, and under the claims table, you can see there is a one DeltaLog folder, and we have the some Fargate files. So coming to DeltaLog, so for each transaction, each write command, it will create a metadata management here. So it will, this file will have the all the what are the changes happened for that record, each write operation. And here you can see the actual data records here. So now I will try to retrieve the data from this Delta Lake. So now you can see the data. We have a two climbs in our Delta Lake table. Now I will showcase the live streaming. So what I'm going to do is I have ran one Python API, so which will create a climbs, and I am pushing to the Kafka, and I'm creating a streaming to the using Kafka Spark streaming. I'm creating a streaming, and I'm writing to the Delta Lake. So for this one, initially I'm not. If you see this one, let me run this one. So now I have run this, and I'm trying to push some data through the my collection. So I have pushed some data. Now if you see the logs here, so basically it don't allow the schema enforcement. This is one of the default feature in the Delta Lake. So it don't allow by default schema enforcement. You can see the initial schema will have the claim ID, policy number, claim data, claim amount, claim type, status, and customer ID. But I'm trying to override along with these columns. I'm adding the another two columns called timestamp and processing time. So by default, schema enforcement will enabled in the Delta Lake system. Now I'm going to uh, enable the schema evaluation here. So I just added one more parameter, option match schema true, so that it will enable for the table we can match the new fields to that schema. So I'm going to execute now. Okay, now it's got executed, and I'm trying to push the data. Okay, now you now read the data. I'm trying to read the data from my climb schema. So you can see the new climb get added here. And now I'm going to showcase the time travel for auditing. So first what I will do is I have climb ID 1 and it has the submitted status. I will make it as a approved. Okay. And now I will see the what exact data is there in the Delta Lake. You can see climb 01 has the approved status. But if you want to retrieve the old history data, let's say version of 0, so you can see here. Let me run this query. You can see climb 01 and status is submitted. So that with this feature, we can retrieve any version of the history. So this is how time travel will work in the Delta Lake. And now I'm going to showcase the schema evaluation. Like schema evaluation, I already showcased. Like if you want to add any parameters to your existing schema. So, but there is another option if you want to enable schema evaluation at the global level, so that you can set this configuration Spark. And here I'm going to add another three fields like a fraud log, fraud score, and risk level. So let me write this one. Yeah, this is done. Now I can read the data from the Delta Lake. So now you can see the climb 04 and it has the new data set like a fraud log and fraud square and risk level. This is how you can enable the schema evaluation and schema enforcement and schema evaluation. These two options based on your use case. Let's say I don't want to corrupt my data, I don't want to add any new fields to my schema, then by default schema enforcement is there. But you are okay with to evaluate your schema in future, then you can set this option. That's it about the Delta Lake features. Now I'm going to cover the what we have. So we have implemented Data Lakehouse system for one of the country. Actually, we have implemented national health insurance for that country. So where we have implemented the Data Lakehouse system for them. So I'm going to just explain about what we have done. So basically here we have used the Apache Airflow as the orchestration tool. So where we can have the either CDC data like capture data change, and or it's a scheduler, it's a Kafka real-time event. We are using Airflow, and Airflow will push the data, execute the Spark job, and Spark will push the data to Delta Lake, underlying data storage as a Minio. And we have used the visual like a business BI tool, and for reporting and all, we have used the Metabase, and there is no direct support for the Delta Lake to retrieve the data from the Delta Lake to Metabase. So what we have done is there is a one open source query engine, Trinio. So Trinio we have used it meta as a database connector for Metabase, and so whenever you run, you create any query. So Metabase basically use the Trinio query engine, and Trinio will execute the query on top of the Delta Lake. So this is how we have implemented. Along with that, we have implemented Melodian architecture also, where we have the bronze layer, where you have the raw data. Then we clean and you can filter your data in silver layer, and you can use that as your ML or AL AI data set. And we have used the business data in the gold layer, where you can it will serve the your BI and reporting data. That's how we have done the. This is a reference architecture we have used for this project. That's it for today.
Yeah. Thank you so much to our incredible speakers, Suman and Narendra, for sharing their expertise today. And a huge thank you to all of you for joining us. We hope you find the discussions insightful and inspiring. Before we wrap up, I'm thrilled to announce that our next webinar is scheduled on 12th of June, 9 p.m. IST, titled AI Powered Call Intelligence in BFSI. In this session, you will learn how AI boosts sentiment analysis, ensure compliance, and delivers predictive insights in BFSI calls. Thank you again for the participation. We look forward to seeing you at our next webinar. Stay tuned for the updates and have a fantastic day. Thank you.
Thank you all. Thank you so much for
Thank
the
you. Thank you.
invitation.